So this is a polycrystalline diamond concept that I had a while back. I don't know if I put it on my YouTube already, but if I did, it's deep in there. But we already had polycrystalline diamond, right? So what they do is they apparently take a bunch of little tiny seedling, micro, small diamond crystal stuff, right? It's already there, and then they squeeze it, and they pressurize it, and they shock it with a whole bunch of electricity, and there's a lot of heat, right? You know, and it's like, and then all of a sudden they'll move together closer, and so on, right? And right, so it's like it's pretty interesting, and they're really, really hard, um, like exceedingly much harder than you expect. G- for what it's worth, right? Because it's like, well, they're like harder, I think, than most diamonds. But like diamond's hard, and then like polycrystalline diamond is like really, really hard, right? But the thing is that they're denser, and of course, they're opaque, right? So if you don't know, like they're opaque, like really opaque. You can't see through like them at all, really, right? And no, this is shockingly not going to get around the opaque problem. So if you're here for that, no. This is actually here to make it cheaper, but also uh, to try and effectively make an even stronger version. That's what this is. So it's like I found out what diamond like carbon's all about, right? And I was like, oh, okay. Uh, huh. It's like diamond. Of course, it's not formed in the same way, and it's pretty hard. It's very, very stiff, right? But it's diamond like for a reason, right? Right. And then there's like, oh, well, there's a bunch of like these little tiny little diamond, you know, thing. Really, what they use for making polycrystalline, right? And it's like, all right, right. Well, I can't make that machine. So like that machine's just like ridiculously large, right? And I was like, how the hell would I make this if I had like no ability to do anything like that, right? Like that's the whole point. Like I need it to be way cheaper, way easier, all these things, right? So it's like, all right, how the hell am I going to do this? So then I learned that it was like, oh, right, yeah, no, they're electron orbits, and then like if I squish it as a plasma, but it's like it doesn't need to be a plasma in a moment. It only needs to be, technically speaking, viewing itself as if it could be a plasma in a degree of a moment in time. And so I was like, all right, well, if I pulse electricity the right way through it while shoving a fuck ton of really powerful electromagnets, that's really what this is going to turn into, right? And it's like, well, there's still pressure. Don't get me wrong, but it's a fucking like get the arms out, get that jack. Yeah, I got get the get that weight on there. I'm gonna get this done. Get that pressure down to like just some, fucking basic ass off the shelf hydraulic jacking, you know, uh, yeah, presses, right? So it's like that's all I can really kind of do, like for what it's worth. But it's like if I know what I'm doing with this electrical flow thing that I talked about, which instead of electrical flow thing, it's like I'm just trying to go watch these videos that I just put. Just go watch those. They're a little bit earlier than this, so go watch those ones. Anyways, it's about the magnetism one. So it's like that's a very specific type of current, which isn't really a current. It's really opposing things, but then it's not really opposing. Anyways, point is, it's converting electricity put into cables, copper cables, to make those electrical, electromagnetic things, right? Like the magnetic fluxes, right? And so it's like, well, I know how to do that better now, and I know how to make it way stronger with a lot less electricity. And if I learned anything with electrical flow, it's basically a pressure wave and then fields and then, movement of electrons in orbits or skipping off of that, depending on how you're doing it. and how you view it and the kind of fucking ones that you end up going with in terms of like the standard model and probability of it's stupid stuff after a while. It's like getting deep into the woods over there. It's like, no, it skips. It's like, yeah, no. Or like, no, this is a cascading tunnel effect. Or no, this is a pressure and this is the water and this. They're all the same after a while. You're all describing different things. Oh, wait. No, you're not. And then they all argue and then I get bored. So I just leave it alone to like, all right. So like essentially this one turns into, well, if I pulse this right with a decaying electromagnetic field that alternates through this substance, then I'm able to create minute moments and little tiny areas during and underneath these pressured moments, especially if I just because I pressed it down doesn't mean I can't then have this basic thing called a vibrator, otherwise known as an oscillator, right? So it's an impact wrench. That's really all it is. It's like, but it's like, no, I need it to be at this kind of frequency that matches for these in between moments for this little area, and so I have to know this density and this fucking size and shape and so on. And so it's like, all right, well then if I model for the resonant frequency and tune of that given type of size and shape of these diamond and diamond like carbon, right, that are in there, then it's like, oh right, yes, then I can do that. But it's like I also have to take out air. I have to vacuum it out very hard, and I still have to run a damn good amount of heat into this system. So just because I pressurize it doesn't mean it's super, super hot all of a sudden, right? So it's like, no, this has to be pretty hot still. There's no getting around. It still has to get pretty hot. So yeah. So that one turned into, well, how the fuck do I heat this bastard? Is there lasers out there I can get? Is there any lasers I can make? Oh, yeah, no, there's some fucking lasers I can get. You know what? I'm just gonna use oxyacetylene in some lasers in a vacuum effectively. So it's like the oxyacetylene kind of like transfers its heat, right? But I don't want it to like actually do anything to, like the oxygen or something or any of that. I don't want that, messing up with the highly pressurized vessel that, of course, this has to be in. Okay. And I have to have all of the air as much as I can get out, like literally as much. So it's like I'm heating it up, and then it's got the vacuum pressure, like a little vacuum pump. So it's like, get even more out. Just keep doing that for a while. And then it's like, all right, I'm going to keep squeezing it for a while. But it's like, no, you don't even understand yet. I know, shocker. Turns out I, during that, have to do this crazy thing called making magnetic and electrical things occur. I still have to do that. So as I'm pressurizing it, I still have to push that in there. And this is the weird part. Okay, it's like, no, I can't do very high volts. I have to do very high volt in the sense of very high flux magnetic strength. Okay, but I have to do high current, lower volts, much lower volts than you would expect. Like 120 is no, not a chance. Can't do anywhere near that. I can do at most 5 to 12 volts. That's it. But I can run massive current. I need to. But like massive current means problems. So I have to pulse it. Right? So, anyways, as I'm pressurizing everything, I have to do all this bullshit, right? But it's like, no, I can make it at home now. Eventually. It's a very eventual. Because it's like, no. That laser stuff takes over from initially getting it hot, initially getting it to the point where like, oh, I've gotten out all the air and all this other stuff and I've been squeezing and everything. It's like, that has to go now. And then it's just using light. I have to use light, but then it's like, not just any other light, because the vessel that holds this shit, guess what? It has to be fully transparent to this light wavelength. because I have to keep it hot inside, right? And it has to be strong. So it's like, what the fuck is this vessel made out of? It's like, oh, surprisingly, it's boron, fucking whatever the hell it was called, but it's that really hard boron shit. And so it's like, oh, great. It's like, oh, and that narrows down dramatically what kind of wavelengths you have to use for the microwave and IR, right? So it's like, what are those magnetrons you got over there, bitch? Give me some of those. You got some IR emitting devices. Oh, my contraption of stupidity, of high volts and currents. That's what it felt like. I was like, oh, I could die so quick doing stupid shit. Anyways, but you can do it, right? So you can do it, but it's like, whew, that's a lot there. But you know what you're doing, and you should be careful no matter what. You're not gonna get hurt. But like, yeah. Anyways, they have to fire Malaysians, and then this is a pulsing, so very high degree, and it's like, no, IR is nice for IR emittance, but it's like, no, no, no. If I use microwave to increase the degree of let's see here, instead of CO2, which like CO2 can work, but CO2 is not really the best thing for this one because we don't really want a interference pathway for the IR and microwave. They're high, frequency microwaves, and then there are lower. There's a big frequency range of microwave, right? And it's like there's a very specific band gap here, which isn't what they call it, but it's like frequency of light wave that will pass through this thing. So it's like I have to match this fucker for there's only this IR. And then you guys don't make it easy. You don't really, I'm just letting you know. I mean, at least you can tell me online easily what this is that I need to do, but otherwise, you're not making this easy. So it's like now I get a vacuum tube. I have to get a whole bunch of like reflective material for that specific wavelength. It has to be thick enough for the IR, and then also the microwave, which the microwave is its own thing because it's like, no, if I produce magnetrons with this set distance and this interference pathway, meaning I get this constructive, but it's actually really destructive for me, but then it turns into the exact right at this distance in this magnet with these reflective for this microwave and IR to combine with this interference pathway, with these pulsing, with this electrical signal pulsings, with this impact mechanical pulsing, with this pressure that it's under, I then inertially confined and also massively increased heat and electrical movement. Right? I get a positive, then I get a negative. And then I created polystructural, which isn't really technically what it's called, but I'll go with that because I don't know what the real word is. But it's a polycrystalline, sure, but there are multiple polycrystallines. So it's a polycrystalline structure, right, that then repeats itself. So it's a disordered polycrystalline, but then that disordered polycrystalline structure repeats itself, right? And it's six-sided connection, like like all that, and then they slip in between each other all the time. Like these multi-lattice structures just slip in between each other's lattice structures, and then they combine in multiple different six and weird fucking ionic fours. It's just like, no, there's a four, like big strong, the big one, the covalent, or not covalent, whatever the fuck it was called. Anyways, but then there's like these two ionics over here and then they'll move slightly, but then they don't really because it's like, no, 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 you have to move against these things that are the true sixies. You got this total six over here, and then it's like, no, I don't wanna. But you know what that means though is I now happen to have a space here that allows for this to slip inside. And then it repeats itself. Super opaque, very hardcore dense. Super dense. Like a six-sided die, regular size six-sided die, standard stuff, right? Of diamond. Its weight will fit within inside of like fucking like a pea-sized, you know, polystructural polycrystalline diamond of this size. So it's like, cool. What? Right? Like that little fucker is now in a pea-sized little, same weight, right? So it's like ultra dense, ultra compact, a lot less pressure. I'm basically making moments of plasmification in very specific areas that allow for this, and it just naturally wants to form. So like you don't have to individually build it up in this little tiny, and then like laser, fucking welding kind of. No, you don't have to do any of that. No, you just gotta fucking hit it. That's all you gotta do, and it'll just form itself. But it's like these are uh, fucking instead of resonant frequencies, they're very specific frequency impact things. So it's like um fucking see our diamonds like this fucking six thing, and so like this is based upon the vessel size, shape, and then you also have like how much diamond like versus how much actual diamond that you're using, and then what the pressure is that you're at as well. So like this is the big caveat asterisk. There are going to be calculations here. So it's like, depending on your ratios here, depending on your size and shape, depending on how strong your light sources and your preheating and your vacuuming is, and how strong which by the way, I'm using my in that other YouTube video for how I make magnetic flux using electricity, that to do this versus like I just use alternating current or stuff like that. Yeah, I mean, which they're in there, sure, but like go watch that video to know about that. But that's a opposing current line and pulsing and alternating current. So like there's DC and AC both added, and then there's a specific mathematical algorithm I'm using to make that happen, to resonate and make electrical fields that strong that way. So it's like, oh yeah, no. Still, is a really good way to get around. Like, I don't need to buy a massive tube of copper to make this happen. Instead, it's like, no, I just need like a decently thicker gauge, and then like it's around it, right? So, like, I don't need to do any of that stuff, which is the whole point of that. It's like, no, I don't. That's a lot of money for that amount of. It's not like these diamond like carbon or just regular little tiny diamond things, seeds are cheap as fuck either. So, you know what I mean? It's same thing with the whole like hydraulic press and all of that. So that, anyways, that one turned into the size and shape, like depth. Let's go with like let's say it was a box. Fuck boxing, no, fuck the damn box. Boxes suck. The corners always just suck actually. They get squeezed into it, and then they create like more pressure in that area, which just isn't worth it. So you can't use boxes. You have to actually use like a more of a cylindrical or ball shape. Like I don't think they ever make ball shapes, but if you have them, I suppose that'll be really good if you can, more specify like that kind of shape in that one little central area. But no, I used a cylinder. That was as easy as it gets, right? It's super easy that way. So there you go. But I guess maybe use a box if you want to. But a cylinder is easier because it spreads all the. Anyways, point is, let's go with that. Let's say it was like an inch and yeah, just an inch all around, inch diameter, inch depth, all that kind of thing. Right? It's pretty simple to understand that. But fuck it. It's 2.5 centimeters for you. Exactly. There's no, the twos or whatever. It's just 2.5. Okay. For you metrics, which by the way, that's way better than freedom units over here. Uh, I prefer them divide by 10 than whatever the fucking weird ass ratio algorithm bullshit they're going on with over here with. Yeah. But I still maintain Fahrenheit is a much better temperature measurement in terms of like if you in your body is in it versus like if you have to measure it on something, which in that case you have decimals, so it doesn't matter. But otherwise, if you have like 1 degree of difference of Fahrenheit change, like you can kind of feel that. And by kind of, I mean you can really kind of feel that. So I feel like it's a better measurement system personally. So, anyways, uh, right. So you have the inch and an inch, right? And then that one turns into what are your ratios? Let's say you have a half and half. It's just fuck it. We'll go half and half. Although you're not supposed to use half and half at all, like in any way. You're supposed to use like at most a 72% diamond like, and then the rest are regular seed, right? Diamond crystals, but you can play around with that ratio down to about 50-50, I suppose. So let's say you were 50-50. Oh, that's gonna be harder. Let's go with like an easier one. Let's go with like 58, percent diamond like carbon, and the rest is the seeds. Okay. Let's do it that by mass. Okay, we're doing it by mass here. Did you measure it in a fucking vacuum? There's water and liquid in that shit. It matters. It's gonna matter a tremendous amount later. Like that water is not good. You have to dry this shit hard. You have to genuinely get rid of any and all contaminants. So it's like my whole thing turned into so it's in a vacuum and I'm heating it up. Oh, but also irradiate with UV, irradiate with anything that burns any fucking stupid things. What are those microwaves? Brrr. It's gonna fucking make it so there's nothing in there. They're clean as possible. Good to go, right? Turns out I lost like a real damn good amount. Like, you think it's not much, but when you're measuring this really hyper precise kind of stuff, yeah, it matters. Okay, like it matters a lot. Like you can have air. There's going to be air in there. There's going to be nicer or whatever. Like you can try your best with the vacuum pumps and all that, but it's like there's always going to be some amount in there, right? So you try your best, but like definitely you want to clean them. So, anyways, but 58%, and then if I can, 50, I should be able to do that in my head, but I'm not. So I'm not perfect. I think it's 42%. I'm pretty sure, right? But we'll just go with it is. Okay, something like that. So yeah, the 58 and 42 ratio. All right, you did everything, you cleaned everything, even the boron, like really hard stuff, and like the vacuum pump and how you connected it, like all of it has to be clean. So you did that. You made sure it was sealed, which by the way, I never talked about the seal. That's a whole other thing. I should talk about that. Fuck. Let me see here. So I did the weird person thing where I was ultra hardcore specific about this. Where it was like, no, this cylinder is actually technically not there until it's there. Which I know that sounds so stupid, but it's actually not. It's like, no, there is no actual cylinder, so I don't need to seal anything. And then it seals itself because now there's a cylinder. That old trick, right? Which is like not really a trick, but um that doesn't describe anything, so you have to actually describe how that works. But that's how I view it when they do this. So it's effectively like it's quite hot to begin with, right? And it's already in a vacuum, okay? And then I'm heating it up, and what the material is the boron silicate or not silicate or fucking whatever it's the hardened one, right? Like I forget what the fucking hell it is, like a Q fucking something. I don't know. Anyways, point is like the cube boron whatever fucking thing is super cheap, quite hard comparatively to like a lot of other substances. So it's pretty easy to get. And they usually use these as reaction, or like you can put them in a microwave and heat things up inside of them as like an oven or something, right? So like that's what that is. But anyways, you're expecting me to be like it turned into glass or something, and then there was a cylinder. No, 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 no. You can't do that. Cylinder wasn't there because it technically wasn't there. I know. Shockingly, that makes no sense, but it's like, yeah, pretty much. I squeezed both of these things already together. They're effectively plates with some donut shapes, right? And so like, and then I did all the sucking things out, but then there's like multiple little wavy things, right, throughout, and then like you have to just slightly turn the thing, and then like that allows for it to, basically latch onto itself and effectively kind of makes it so that there's no gap of any sort, especially as it expands because it's getting hotter. And so it's like it's welded quotation marks, but it's not. And there is no cylinder whatsoever until there is one. That kind of thing. But it's like, no, but you see, the thing is, I then have plates in the center of that you then press, right? So it's like you have the outer, hollow tube that then places these plates, and then it's like, then you have it there, right? Right. And then you like squeeze the other plates in the inside, that kind of thing. That's literally what this is. But anyways, that allows me to do the whole vacuuming and the heating up of that and all that stuff and setting everything up, right? And then I can vacuum out that, and then I can place in the ratio, which, by the way, real careful. You have to do a literal vacuum vessel, and then you have to attach that because after you vacuumed the tube, the hollow thing, which has to be sealed, by the way, you then attach this, which is another vacuum. So hopefully there's no introduction of any kind, of any sort, of anything. Except that's not how real world works. So there's probably something in there. Darn small little micro nano sized bullshits. You know, oh, it's slightly chipped a little or whatever the fuck it is. So, anyways, that pours in. You get that. Hopefully, it mixed properly during all of that because, like, it's just like espresso puck prep, right? When you pour in espresso grind and then you have to like do the whole moving it and to get the bottom all nice and like uniform, and it's like, well, hopefully you did that. Hopefully you have like a stick. Hopefully it came in all the right way. Hopefully all that, or do the stick thing or something. I don't know. Figure it out. I did a vibrational stick thing. I was like, I poured in, and it went "Nyeh," with the impact wrench, and then I got a little stick, and I was like, yeah, and just fucking figure it out or something. I don't know. It's not even a joke. I literally, and I stuck that fucker in like the little plungy, like, oh, okay, this is the same plate. And it's like, what's the seal for that? And it's like, effectively a whole stick. It's real tar, and then there's like these little lines that go through, and then as you go through, and then you have to spin it, and then you have to do another one, and then you spin it again, and so it goes through like multiple fucking versions of spin until eventually it's just slide down, and there's still like a like actual gasket thing, which that one is a whole other thing. I ended up learning like, oh, gaskets don't go to like, okay, give me a second here, that's bullshit. Oh, fine then. I guess I'll just fucking make a gasket, I guess. It's got to be a metal gasket, apparently. Let's get out the brass. Yeah, no, right, brass, but no, 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 that's just regular brass because of the amount of pressure, and we have a vacuum, so it has to be vacuum sealed brass stuff. So if you don't know anything about vacuums, everything likes to come in. You know what I mean? So it's like, well, great. I guess I'll just heat up this area and I'll just extra squeeze, kind of slightly weld-ish it, right? That's literally what I'm doing. Not even a joke. It's like I'm just gonna heat up this, and then it like squeezes in, and it's like, it's mostly. I'm gonna pour some fucking fluid, hopefully, in there, just which is like, by the way, fluid turns into its hydraulic fluid, right? Like it has to move down. So it's like both getting pushed from the top with the hydraulic fluid, but then also this thing. So like it's really quite centered. It's not going any other way than exactly where it is, right? So super hyper precise stuff. Except not really. This is just like whatever that is. Anyways, back to the fucking 1 inch by 1 inch cylinder about how to do the ratios. All right. So it's like, right, we already got the ratio. All right, what were we talking about? The current, right? So the current would be like, I'm sorry, that's amps. That's current is not amps. That's fucking so stupid. I still get angry with this thing. Anyways, it's it's amps. So the amount of electrons, which effectively turns into, so you know what the amount of ratio of your diamond like carbon and your diamond is, right? Like these are the amount of electrons you have, most likely in any of them, right? So like the basic math turns into, if you calculate for all given that mass value of those electrons expected in that, all things considered, you then go and multiply this, and this is how easy it gets, by 1.4423 times. That's right, 1.4423 times. And then you get a divisible number of the type of current that you feel comfortable with for that number. But you don't want to go past anything that would literally melt and burn everything. So as a result, you go with, oh, right, yeah, that's too much. So no, let's look at that 200 maybe, maybe two, whatever that is, right? And it's like, if it's divisible by that fucking number, then you're good to go. That's the current you go with. It's the easiest way to get this done. Otherwise, you have to go to a bunch of fuck that. Calculate for a number of fucking electrons in those orbits. That's all you got to do. And then you go, and 1.443, whatever the fuck it was, right? Because I'm already over it, right? But it's like, effectively, if you get 443, you're good. But if you get to that thing, then it's like you get really, really good results. So, right. You should remember, right? Dude, I just don't ever fucking want to keep everything in my head that way. Like I'm on a roll. I'm trying to get. I'm still. You know what I mean? Come on. I think it was like 8-7 or whatever it was. I should have wrote that down. Anyways, I'll listen to it again. In the future when somebody asks me how the fuck to do this or something, I don't know, and I'll use that number, and that'll be the right number. But it's like that's your current value, and I know that sounds stupid, but it's actually the best way to do that. It's not even a joke. So that, right? And then volt can only be up to 12 volts. All right. So take your pick. You can't go lower than 5. You can't go above 12. Simple as that. All right. Then electromagnetic flux is a different story. Flux turns into, okay, so then how are you producing it? Because if you're using alternating current, then that's a whole other thing. Like if you want to use regular like coils, uh, if with regular circuits that are not a part of my stuff, then That's a whole pulsing change system that you have to do. Mine is just like automatically it does this thing. And I don't have to worry about it. And it effectively goes into I only need about 12 volts and about like fucking 10 amps. Yeah, 12 volts, 10 amps, and that'll work. A few, like a couple of watts basically, right? And it's like nothing, right? And then the frequency just turns into whatever the opposing, opposite, and then a in between sine wave of the impact wrench. So the impact wrench then turns it into okay. So it's an inch by an inch. You go with this is the resonant frequency. If you have this material that's in there, then it's like it'll propagate like this at these densities at these speeds. So you calculate using that, assuming a roughly equal, plus or minus about 5% distribution between any of it. And so it's like that resonant frequency will propagate like this as a wave, right? Right. And then it's like, then you'll use that for your impact wrench. But then you use a secondary that goes slightly offset, slightly behind, or slightly forward, right? And then you stick the electromagnetic right in between that with my electromagnetic, which is flux, and making the big old field, right? But it's like, right. But if you don't have that, then you have to do a different pulsing sequence. Instead of Fibonacci or any of this other stuff, this one turns into a weird, stupid fucking sequence that I hate. Well, not but frequency, right? Because like you have a frequency of alternating current, which is something you don't often account for, right? In your coils, and if you use DC, it's like that's great, but like then that's a whole other thing that you have to do. Yeah, and it's like okay, but you have to hit it from one side and then an opposing side and then a diagonal side. So you have to do vertical, horizontal, and diagonal, and then you have to be very particular about how you deliver it, and it can never go to the next one. So if it was horizontal to vertical, right, it can never be vertical. It'd be horizontal to diagonal, and it can't go back to horizontal. So you'd say it'd go to vertical, but it actually goes back to diagonal because it can't go to the next one, which would be vertical. And it can't go back, right? And so it's like, then how the fuck does that work? Because you had a slight delay, then you're actually now able to do your verticals, which then you're allowed to go back to horizontal, which makes fucking no sense, and I hate it. But that's apparently how electromagnetic fields collapse with the current that you're running through and a pulse, which, by the way, didn't talk about that, but that pulse, that's a pretty simple one. It's definitely directly related to the both electromagnetic firing pulsing sequence, but also your impact range sequence. So your impact has that slight in between, right? Right. So the current that you're putting through needs to be directly in line with both the first hit of the impact, right? And the in between magnetics. So those are the two times you got to make sure you pulse it together with that. And then you'll have a third one that directly makes sure that it runs only when none of those things are doing that at that moment. So there's no electromagnetics and there's no impact, but because you know the resonant frequency, you know the size and shape of your vessel, and you know how it's going to propagate and where it starts for your electrode and your introduction of these given electrical signals, then you know where and when and how to propagate the electrical current wave through the given substance. So you can do top and bottom, anywhere in the sides, and as the wave travels from where it began, where it's entering, then you're able to introduce it like that for those given pulses. Now, if you do this, great. If you use standard electromagnetic from coils, then you have to do that weird sequency bullshit, which, by the way, I didn't talk about how strong those are. Those are going to be a lot stronger than mine. those ones are going to be the equivalent of, I got a big boy electric motor. That's right. You know, there's Tesla plants. Well, I'm not that strong. I mean, I'm strong though, but I'm not that strong. Doesn't need to be that strong, you know. Which hopefully you didn't introduce anything in this whole contraption that's gonna like be ferro or electromagnetic in any aspect, or even have eddy currents, because you can't do that. So it has to be ceramic, or if you use mine, then you don't have to worry about that, and then it's fine. But since you probably aren't doing that, then you do have to worry about this now. Yeah, I know, right? Shockingly, that sucks. Who would have thought? So now you have to get a whole bunch of fucking ceramic or non-ferromagnetic material that can handle really high pressures. But luckily, they do actually have those, because we're only talking about like a basic bitch jack kind of hydraulic press. Now it's on a bigger size, but it can still fit on a desktop. So whatever, right? Good to go. Now, I didn't talk about the electromagnetic because it's like, we're going to be talking about a 240 volt, and you're going to be hitting max amp from a circuit breaker to run that. But it's still doable, but now you're doing that. Or you don't have to do that, and instead you can use mine. You go to that video and figure out how to do that type of thing instead. But you probably didn't do that, and you're going to use this. So 240 volt and max amps for a circuit breaker, it is. So, anyways, now we're going to talk about pressure here. This one is like effectively 80% of a max of like a larger. That's, I mean, I'm averaging out here. So, hmm. Um, all you need to do is hit roughly 150 kilopascals per square inch. So since it's an inch and it's not a square, but it's roughly a square, 150 kilopascals. And considering you can actually kind of easily achieve that with a design like this, because like you can hit the outside at a particular pressure, right? But then you can squeeze the center harder, and as it gets hotter, you're going to continue to squeeze it. Right? So that way it maintains those kilopascals, right? So you do that. You have to be really good with those coils, by the way. Those are thicker bad boy coils now that you don't want to use my version of it doing that. But anyways, I suppose you'll just have to make do, I guess. But then the oxyacetylene, right? It's like right. That is pretty simple because it transfers heat. Right. So it's like, instead of like, oh, you heat it up ahead of time and then you put it in everything. No. It's as is, and then you're heating it up, and then you're making sure to maintain the pressure. 'Cause you hopefully got a pressure gauge in that little plunger thing that you got there, or at the bottom for the anvil, whatever it is. Right. So hopefully you got that. That can handle those kilopascals and those heats. If you don't, fucking, I don't know what to tell you. It turned out pretty easy to find those, but like, that's online in like certain stores, right? If you search for, high heat kilopascal, apparently they do sell them. But my version was effectively like, oh yeah, no. Well, this case, but if this spreads, okay, so, but if it is expanding and then it moved it because it needs this amount of heat and this amount of pressure at this condition for friction to equal this amount of distance traveled, which will then mean that's, and if I move this needle like this, then that means it's actually at this amount of pressure. Which then turned it into 150 kilopascals is basically what I was at. But you don't have to do what I did. You could probably just buy that. But if you want to, go ahead. So there's that. Anyways, um, see, and then that's the pulsing sequence. But if you add, these are all within the same, like if it was flat, you had a vertical line, you had a horizontal line, then you have a diagonal line. And you turn it to Z, if you had a secondary Z there that's diagonal, then you can finally run a basic bit sequence that is a lot less fucking phenomenally annoying to run. But you always have to have a fifth of a pulse of all of them at once. Yeah, I know, right? So it's like you can do horizontal to vertical to the Z diagonal to back to the uh Y whatever diagonal, right? Yeah, and then you have to pulse all of them, right? So, but you can't really do vertical, right? Well, yes, that's the thing. Because you have a fifth all pulse, then you're able to do that. But it still runs better for what it's worth if you can do the Z after the horizontal or the Z diagonal, and then you can, right? But if you have the all pulse, then it's like it's not really, and then it's a lot easier for a circuit design to just do it that way than like the other way. But if you want it even better, then it's like, yeah, no, do the Z, and then like you still, but whatever. That's me in my mind. So, anyways, and then the electromagnetic radiation, otherwise known as light, here is IR and microwave, and we have to have it constructively interfere. So luckily, this is the best part because it's like, yeah, no, it likes to form a inertial confinement, sure, but it's also really, really hot. And when I'm pushing that kind of current and I'm pushing those electromagnetics, it forms those ionic and covalent, whatever, doesn't matter. Point is, those types of bonds that are really, really stupidly strong, and it goes to some six-sided, or most of it's really six-sided, and there's like a couple there that are those ionic for those two, for those four, right? And then that turns into where it kind of jiggles, so it'll slide through itself, and then it'll form over that. Now, this one, shockingly, which is the whole reason why I really did it, because it's supposed to be really cheap and super fast to make, right? And stronger, right? So it's like, well, instead of waiting for weeks or whatever to grow this fucker, which hopefully you have like a shape for like the top plate and the bottom plate that's inside of the other plates that you like, because otherwise, you're just gonna have a disc that's kind of not really able to be used for much of anything. So, a real nice paperweight though, But if you do have a shape, then it's like, behold that for something. Whatever that is. I mean it. Like, I don't know what to tell anyone because, like, a plate's still pretty cool, but it's one of the most reflective and thermally conductive materials. So, it will reflect basically everything except for like very specific radio waves, which are really long, anyways. And it'll still curve radio waves, right? So, yeah, I like it for that. And gamma waves might as well be called, yeah, no, I'll just turn into a bunch of heat, turn it in, you know what I mean? So it's just like, be gone, Gamma. From this small spot. Or 1 inch, 1 inch of gamma wave protection. But if you think about it, it's like, well, like, sure, it's a 1 inch depth, but it's like what ends up as a plate here it's no longer going to be an inch. It's more like a millimeter at most. It really depends on ratios and how long and everything. But yeah, no, this will take a day at most. Like, truthfully, you can get it done in about 8 hours, right? So not bad for like an at-home project, and you can just like set it up to be automated, with some Raspberry Pis and Arduinos and whatever. You just have to make sure it maintains that pressure, so it just has to go down or whatever for the whole thing, and out pops whatever you've got. So the whole reason why I made it was because it's like, well, I like cars, and this is really hard and slick and thermally conductive, and if I dope it right, I then have a really really cool type of PCB that is stupid as fuck. It's super super electromagnetically like just resistant, I guess. Like to EMI, any charge, any of that. It's like a dead zone. It didn't really turn it into heat. It doesn't seem to reflect it, but it certainly absorbs it in some aspect and prevents it from doing things. So that's what that was for. But the reason why I wanted to use it was for cars, and I wanted to make a really, really, really thermally efficient and very high thermal mass type of. I don't know if you can hear that. It's over here. Yeah, it's a pan hitting my stove for skillets, pans. So I was like, well, if I use like some aluminum and some aluminum sheet that is, and some steels, right? And then I put this at the top and the bottom, and it's Swiss cheese, right? The little plates of sheet, right? Which they're not plates, they're sheets, but like, right? They're like a skeleton essentially. So I put this on there, and then it effectively can weld to it. You can use aluminum or copper. It doesn't really matter. I use aluminum because it's easy, you know. But it's like if you put these together, then it creates a very dense, very hard, very non-stick. It's extraordinarily slick. But it's like, well, I have this plate, right? So it's like if I know what I'm doing with this coating, and then if it can only ever blade away, meaning wear away in any kind of form or fashion, it's like, well, it can only be with these kinds of, and so it's like, oh, since it's polystructural, meaning it's really kind of polymerized as a polycrystalline diamond. It's a polymerized polycrystalline diamond, right? Because it's polystructural. It's the same structure kind of repeating itself, but it also has multiple poly structures, multiple structures, crystalline structures inside of it that repeat themselves. So as a result, it's like, oh, well, that's really good. It's a very high thermal efficiency. It's really easy. All I have to do is make a plate of it, and then I can just and pop them out. And I was like, right. Well, also the shape of the pan matters a big deal. So like how the sides flare up, how that convection comes in, because depending on how it wants to curve back down, right, that can cool off the sides more than I would prefer. So I shaped it with like this weird kind of conical trapezoid outward bound shape that then also has these little flaring kind of waveguide fins and these little channels and grooves on the inside, grooves where the little lips are, that at first they're like, well, they're non-stick and there's less surface area. It's like, yeah, no, okay, sure, yes, sure. And it definitely does do that, right? But it also happens to mean that air travels upwards with that, and it creates a different type of convection as it'll swirl at the ends, and then a little bit of it will go towards the center and then come back as it'll go back up and then vortex back up. So a lot of the heat stays in the pan that I as I want it to, right? But they're not sharp little waveguides. You can't do that because that's dangerous as fuck. No. No. And they're not many multitudes. I only want like fucking a few, so you can have it effectively be such that you can, pour or, place and so on from the pan directly or a skillet, however you want to call it, just all of them are good, onto the plate or the bowl or whatever it is you've got. So those are like multiple, directly vertical 12, and then you got your three and your four, or your three and your nine, and then you got the in between for that. And of course, there's a handle there, so you can't do that, right? But off to either side, basic stuff. But it's like, behold, really high thermal efficiency, but you have to be really careful. The moment you have it at that heat, it's that heat, and it really evenly diffuses itself, so it's hot all around. Very low temperature gradient, especially with the little air trick I'm doing here, right? So then, because this gets rough, it means whatever the temperature of your burner is, whatever type it is, that's what you're getting pretty much all the way around, except for like kind of the tips and the very outer edges, right? So it's like If that's a lot harder than it needs to be, it will very quickly transfer that, and it'll immediately get that heat basically right back to it itself, because even though it has a high thermal conductivity, it also has a very high thermal mass, so it acts like a thermal battery. So it'll immediately place it right back in, and you can burn things very quickly. It's super non-stick kind of coating, but it also has like the little divots and that kind of structure kind of thing, so that way it like slips off easily, right? And it should last for the life of it. And it's also able to bend slightly, although it will chunk um, eventually. You know what I mean? It's like the equivalent of like um, what do they call that? Normalizing cycle, or like heat treating cycle for hardened steel, right? Because like you get, it's really brittle, right? But then it's like once you do that, it'll bend a little bit, right? And say, oh, that's great, that's perfect, right? Yeah, but if you hit it the right way, it will absolutely crack. It'll absolutely split. It'll absolutely break. So don't do that. But that's also one of the reasons why the shape helps it, because it like has all those little bendy, absorbative kind of shapes there that also help with the air too, right? Uh, as for engine stuff, it was like, well, this is super easy to make the inside of cylinders walls, right? Then bearing journals, and even balls, if you want to make sealed bearings, because they're super hard for thermally resistant. Like they don't give a fuck what the heat is. Like it takes a ridiculous amount of heat for them to then turn into something that breaks down in our atmosphere of any kind. Like I poured oxygen onto this with an oxyacetylene, just trying to fucking get it to burn, and it didn't really want to do it. I got it to you know slightly wear away in one spot, but it's still pretty glossy. So it's like, okay, right? I don't, but that's the best I can do right at home. Maybe someone else has got one of those plasma, ridiculous, like 10,000 C torch die. I don't have that. I had an oxyacetylene and some extra oxygen, and just like, "Ugh." So it didn't do anything. But that's, imagination, knowing how things work, knowing how bonds work, knowing how things like that happen to work, right? Like I'm very aware of those things. I'm very much able to just imagine that very accurately, right? Other people might not be able to do that, but I can do that. So that's why I end up having a bunch of these stories and, oh, you do this and all that. It's like, right, right, except they're not really stories. You know what I mean? And then like, oh, this word, and it's like, actually, right? I love the ums by people. It's like, well, no, but that, it's like, where are you going? Oh, is this something that makes it so you want to try to make diamond-like polystructural polycrystalline polymerized diamond? You know, because it's not diamond though. It's very opaque though. But maybe one day someone will figure out a way to make it less opaque. But I've never been able to do it. It's just super hard stuff, super slick, very, very resistant to like anything, no matter what the temperature is. So I was like, fuck oil, screw pumping. I'll just put it in some like low pressure or whatever the fuck, you know. And then it's like, oh, behold, it thermally transferred to some piezoelectric vibrational bullshits. Because turns out if you make them thin enough, these these fuckers don't only just transfer energy really well, they'll make energy. And if you dope them a little bit with some piezoelectrics, they'll really make energy. And then if you do even more with a little bit of a magnet and coils right inside with some piezoelectrics that are built in, because that's the whole point I was trying to make with like, well, it's like a PCB, I could put some stuff in there. And it's like, well, there's a reason why I wanted to do that. Behold, the engine that is cooling itself to make electricity that then has the piston. You get the picture. It does a lot of work energy. It's very, very thermally efficient. It's the whole point, and it doesn't wear out like ever effectively. Uh, I haven't been able to do it. So, you know, there's that. But that's also the other part where it's like, no, there's now there's just this plate. Oh yeah, no, but it'll never be sharp or anything other than that. No, no, well, yeah, right. It's like no, it'll the environment or something. Sure, sure, yeah, yeah, no, but I don't think any of them are going to care because none of them are going to be nano-sized in the slightest. So I don't think they're going to matter or care about it at all. It's non-reactive to any of our fucking biological processes, and if they're that small, they'll just pass through our gut. They have to be in the like micron to nano size range to get into our body. So very unlikely for any of that to happen. I mean, again, maybe someone's got something to break it down. I've never been able to for any heat or frictional, even without like any lubricant. It's just like, "Nyeh." There's just even a little bit of air, just a small amount of air gap, and it's like, "Nyeh." I guess now I have no friction. Is what it seems like. It's not, but like it fucking seems like that. After a while, it's just like going and going and going. And going. Are you gonna stop at some point? You're gonna stop? There's at some point, maybe. I don't know. I don't feel can feel like it. Okay, I guess. But that's good though. I mean, I had a flywheel. Like I just spun up to like 10K, and then I waited like a year for it to slow down. Now, granted, I have a vacuum around it, but it's a basic vacuum pump stuff. You know what I mean? And it's not gonna, add its energy into anything, right? So, and it's on like these bearings instead of magnetic, right? It's these bearings, just friction bearings, right? They're sealed. No, there's no lubricant. So, and then it's like I'm waiting a year, and it had gone down like a couple of RPM. So I was just like, okay, well, that could just be the bleed of the fucking turning of the Earth and it rotating around its orbit. Gravitational bullshit. I don't even know. I literally don't know how to calculate that. I'm like, it's not even 12 fucking RPM loss. This is not even in the tens yet. It's a year later. Oh God. Okay. Huh. So that's kind of the thing with the frictional part. But, again, it didn't have the type of mass, because of course I'm not going to fucking pay for that kind of level of. You're thinking it's a big, ginormous fucking flywheel. It's not what that is. But I mean, it's still pretty large. I mean, it's a flywheel from a car, but it's these tiny little bearings, and maybe with more mass, it'd slow down more, because it's more friction. But yeah, 30 pounds was not that significant, I guess, to it. It was like, whatever. I'm gonna still keep going. I don't care. Depending on those types of calculations and whatnot, it was between like 5 and a total of 8 RPM of loss. So it's like, okay. Hmm. It was just like, yeah, I'm done with this because I don't know if I really ever want to make another bearing. Right? I couldn't score this on a hardness because like that was its own shit show and a half. Let me tell you, you get the Forever pencil or some shit trying to fucking force this into a little mold thing, right? It's like the more complicated the shape, the more difficult the resonant frequencies. And so it's like, well, I was eventually able to get a pointy thing, and so I was like, do something. It's not very sharp. It's kind of blunt. It's kind of the problem. So I was like, can I get any pointy shape? I started getting the box stuff. I was like, all right. And the box has a fucking shit show. It breaks every time at the end. So much pressure. I need to figure this out. And so then I never did, and then I did other things. So I have no idea if anything can like scratch it. I was bored. I was literally that guy where it's like, yeah, I got nothing. Star pattern is basically the same problem where it'll just fucking like crack a bunch of times for the mold. I was able to get like a slight pencil, like, but it's blunt tip. So fuck this. Maybe they'll be able to sharpen one of their own stuff with like the a blading away plasma thing. And does it scratch it? You know what I mean? Because I've never been able to figure it out, personally. Because at that point it just turns into plasma, and then you're hoping that it melts off effectively the right way. You know what I mean? It's like nope. Damn it. This could be forgeable. It's heating up. Oh, okay. You go right ahead and try. I'll be over here, not dealing with that. I got like the substance I wanted in terms of like, well, it's fairly easy and cheap to make, comparatively, right? Right. And then it's like really thermally conductive. I suppose somebody might be able to come up with something that makes it with the right doping or real control over the structures or something like that. That they'd be able to make it conductive electrically. I mean, you can produce magnetic frequencies, right? But right now, I didn't have that, and so if somebody ever does, and they follow my recipe and they got that, congrats, awesome, I love that. That's amazing. Fuck yeah. Super. Great work. Keep it up. Uh, Do that more, you know, because this is really good for a lot of those applications that you would never really, think that you'd maybe even want it for. Like graphite can go fuck itself effectively now. You know what I mean? It's like it's now thermally conductive, or if you do it, I guess, the right way too, I'm sure it could be the very opposite as it's thermally insulative, right? And then it's like, well, then you have like the electrical and electromagnetic, right? And then like that would be great for like plasma or lasers or other stuff. So that'll be good. It was really just meant for like bearings and engine stuff and heaty stuff and coolie stuffs, that kind of thing. Um, that's literally what I used it for. Yeah, no, I basically learned how to like form certain structures inside of like the plates, as I was squeezing them down. Right, and so it's like, oh, now I have transistors, and then if I vibrate them the right way, and I got a really high cool CPU that just cools itself constantly. It's really ordered, thoroughly conductive, like out the fucking wazoo, electromagnetically. It's it'll just basically absorb it, and so like if within a certain distance towards the surfaces, or at the surface, right, it's like, oh well, that's perfect for like types of pin sets, and or just direct electrical connection pin sets together around them. And same thing kind of like with the glass, or well, if it's clear, it's very reflective to a large number of different types of light. So it's like, oh yeah, no, that's a light transistor, right? Kind of stuff. And so that's what I did. I was like, oh, this makes boom, and then stick it in, and then it was done, right? I don't have memory, but it's like, yeah, fine, I'll make memory, I guess. That one's not too hard. It just needs to store like a potential value, right? Effectively, yeah, right, like a charge or something. Well, yeah. So, and then I was like, well, there's a lot of different ways to do that. So I was like, magnetic fields and strengths and gappity things and some light if I want it. Uh, kind of stuff. Essentially, what that was like. Here's RAM. I got RAM now as chips from this. It's a potential, whatever type of potential value you really want, and I can stack it like a fucking ridiculous amount, right? But they're all ovaloid shapes that I have to stick onto things. So that was kind of annoying. And then it was like, oh right, I want RAM that doesn't do RAM problems, like be volatile. So I was like, all right, if I can have this stick around, so what kind of magnets will work with this? Kind of like the charge over there, potential, a capacitor. I mean, a little tiny. They're basically just tiny ass capacitors, aren't they? they're not really much different than that. There's no try to there's resistance. It's like, oh right, yeah, I can shrink this fucker so far down because it's so electrically. Hmm. 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 And then I proceeded to do exactly that because, like, well, if you do the right resonant frequencies, which is like then gonna move it in shape as it hardens and solidifies over time what the doping material is for the impact wrench, and the same thing for the light, right? So it's like I was able to shape that off of that, and I was like, and behold, the hard drive, which is like effectively a ridiculously hardcore hard drive. It can sometimes let out light during that, and a different type of electromagnetic frequency, um, oscillation, as it'll decay inside as it measures charge with either electrical or light based. So it then turned into like, I have so much storage in this tiny little fucking micro SD size like ovaloid thing, and that thing was ridiculous. I was able to get fucking what was it again? Yeah, a stupidly ridiculous number. There's like an exabyte of like information in this little fucker. But that's because I'm able to use like one little tiny cell at like 8 different ways or something like that. But it's like no. But with my programming, that means, and then my dimensional compression and stuff too, which is part of my programming, and then turned it into like, oh yeah, no, well, I mean, I had like fucking ridiculous amounts of cells, anyways, which went down into, um, singular atom size areas, and well, ish, very big atoms. They'd be, the fissile range, but right, still atom size. But it was like, right, well, and this surface, this thickness, and it was like, well, what's the actual? I can easily hit exabytes off of that. Like, that's not that hard. I'm just gonna make it exabytes. I don't want to program that hard. I'll just have multiple redundancies and multiple uh, dimensional compression, things that I run, and I'll just have multiple backups of the same thing because any one of those little things can fail. But it's like you can always grab them with either type of light that you use, um, together with an electromagnetic frequency, pulse. So it's like you push light through, or you try and push light through, and then you use basic little coils and all that, and you're able to get it back from any of them. But it's like that's not really what I would do for its worth, because I have entrances at the top and the bottom, both sides. You just slot it in, for pin sets, tracing, electromagnetic and all that. So that way I could get all of them everywhere really quickly, and it's fairly thin, anyways. So I was like, look at my tiny little computer. It has such a good screen, doesn't it? It's literally just one sliver of bullshit. Like, look at my battery. Like, oh, yeah, okay, yeah. Meanwhile, me who knows things. Yes, my battery. Otherwise known as it's piezoelectrics. There's some reflective, there's some absorbative of light that goes towards the screen. The entire screen can be a fucking camera, both sides if you wanted it to be. That one was fun, right? And then it was like, oh, it's stupidly thin because it's all the same thing. It's effectively just layered on top of itself, in between itself, and all the rest of it. And so I was like, what kind of battery do I need? What kind of battery? So this is all that charge. So it's well, my skin and then air, and then like light and heat, movement, and then it's like no train, and then it's compassion. It's just stores of it. But isn't that like just fucking a hard drive at that point? What's the difference? I mean, I can make a battery that doesn't discharge. It's not hard. It's yeah. Let me just think about this for a second. Like, what do I really want to do here? Like, it's just fucking positives and negatives, and they want to try and balance themselves out. So there's a lot of different positive negatives I can make. Like even with light. Hmm. So it's like, well, I don't really need batteries, but I suppose I'll put them in there. So I was like, I'm gonna make like a really, really hardcore, ultra, just stupidly acidic, positive chemical compound gas that I'm gonna compress in this, and then I'm gonna like do the effectively same, but with the version of an alkaline gas. And they're super dense, and they can't turn baryonic. I mean, yeah, right. Because they're always fermionic or whatever, right? So, uh, and then because I already have this, and they're gonna squish as they solidify and whatnot. I got like hundreds of gigapascals in little areas of this gas, which then turns it a lot more like a uh, liquidy gas under that pressure. So, but it'll never turn into a solid unless it gets cooled to like really close to absolute zero, which you're probably not going to do. So, whatever. But that also meant that I was like, right. And they'll always just keep getting from the capacitors and piezo and pyroelectric stuff and so on, and just turn into more electricity. So they're generator batteries effectively. But that's the special sauce of the gigapascal stuff. Because it's like, well, with this, like, they won't do that unless they go into the gigapascal range, in which case, like, oh yeah, no, light would trigger them to just fucking make another electron happen. You know what I mean? So it's like, oh, well, that's great. It holds a charge just all the time. And then, like, if you're nearby and you walk with a static charge, it'll just grab it. And it, like, takes, like, 99% of that static charge and turns it into battery juice. It weighs like nothing. It's stupendously hard. It's flexible. You pop it up, you slide it. You pop it up, slide it. Pop it up, you slide it again. And it's like, oh, look at this tiny little square. Just put it over there, like a little card, or it's in my wallet, whatever it is. I never have to worry about it bending to the point where it'll break because it's effectively able to do a 180 or 360, and it'll still pop right back to where it's at. It's a real good spring at that point, right? But it's like, which side is the display? Because it's just like a black sheet, right? And I'm like, yes, anyone you want. It really doesn't matter. It really, it really won't matter. It's like, and they flip it. Oh, it's back to being a screen, I guess. Just knows based upon like the accelerator and how you're holding it, and it's like this is the hot side, and this is not. And it checks a bunch of things with its program, and it goes right. That's the screen side now. You know what I mean? And so I was like, oh yeah, and this is like kind of shitty for like glasses because they're that level of opaque. There's no real way to turn them into not opaque. Like they are that level. You could shine a real powerful laser at them, and honestly, you don't want to be on the other side wherever it might reflect to because it'll do fuck all to those lenses at all. Yeah, who gives a shit? Is what it says. So there's that. Um, but uh, yeah, I wanted to try and turn it into something like that, and I didn't manage to figure that one out. Just because it's like, well, it's a screen. So instead, I turned it into these are sunglasses that are really high. It's beyond the resolution of your eyes of pixel density screen that has like effectively an analog kind of like display where it like switches individual pixels and then has constructive and destructive interferences for the light that goes through or well, as it tries to send it to you. So it's very diffused, very very big viewing angle that just gives you these. Like oh yeah, no, if I was looking off to the corner of my eye and you're trying to look through your glasses, you'd see through the glasses as if you were looking through it instead of like oh it's at that and it's just this one screen here at this one camera angle, right? Instead of that, you get like all of them are just multiple little tiny camera things that are pointed all the different directions. But that's because it's now a sensor, right? And then it's, they're slightly on the thicker side than what your phone would be, but they're thinner than most glasses. So, right. And it's like, if you wear them, you shaking your head, you talking, their air exists, sweat, uh, on your face makes enough electricity to keep running, like basically forever. You don't really ever need to charge them, but I suppose throw them over somewhere that and they'll charge. Literally, like blow near them and they'll charge. I don't know what to tell anyone at that point. Like it's like, what do you want from me? Like, here's a wireless charger, I guess. You don't need it. They'll never drain their battery. You know what I mean? Like, who cares? I suppose. The frames are made out of basically the same thing, and so like they're a part of the calculating stuff. They're also antennas. They're also all the like types of things that you need for them to be right, and so you can connect wirelessly or wired. But that's a fiber optic thing. I don't know if people really wanted to do that, so I just kind of like skipped off of that after a while. Yeah, but it was like, oh yeah, here I got my lens of they're perfectly corrected, we'll say, to any of their far distances or myopic or nearsighted or any of that, right? And they have great zoom levels. I'm not gonna lie, they have a really hardcore zoom level, which that one's like reflective property and then like capturing of light of a larger cone area as it tries to like destructively constructively bend them as it captures and interferes back towards where the camera sensors are. um, is it'll push out light, but you won't really see that light because that's usually like microwave, IR, ultraviolet, stuff like that, and pulses it and all that, so that way like it captures more of the natural light, and you get to see that. You have a lot more light collection than normally you would think you would have, but then you also have a bunch of different little like lenses, like a fly does, where it's a what's it that thing called, a compact or whatever it's called lenses. Like a bunch of little ones, but then those are layers. So it's like you have a bunch of little ones, and then like the things that allow for that regular light to go through, those things also capture a degree of light because there's technically a little bit of electricity there, and that's a field. So it gets interacted as it goes through, and then it gets uh, is it coherented, lensed, laminered? It's a bunch of little holes. So as the light goes through, like can only right. Yeah, and then it has to reflect a little bit before it ever tries, but no, 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 we're not allowing that. So no, no, we get it then diffuses and it reflects back, and then you get all of that as one huge sensor lens array, not just the little small ones on the way in. So you get now a capturing of superpositional angles and basically every light wave that we can make. They still look really, really opaquely dark black holes with no reflection. There's none. It's like it's the worst. Actually, just a smidge. I'm not gonna lie. It's like they are like you don't have like the screen that makes sure that you see your eyes on the other side, right? Instead, you end up getting just black holes, and it's like there's no light that comes in ever. I don't care what the angle is. What the fuck is this? Which is kind of the roughest thing. But I'm sure if you get them bright enough, they'll right, they'll reflect. But for what it's worth, I mostly just use them as really powerful, like solar panels after a while, because it was like, oh well, if I just concentrate a huge, massive area, like they have for the heat ones now, which I still can use. But it's like, oh yeah, no, it'll absorb that as direct conversion when it's doped right, and it looks black. Like you don't see the light reflectivity at all. There's no loss of that efficiency. You just get this band at the top of the like tower, and it's just a black hole. It's scary. It's just this ball, bland black hole, depending on right that you have. But it's a band, not bland, but the black hole thing. depending on the tower and the type that they wanted to go with. Uh, which is again scary. It's a little scary when it doesn't matter like practically how much light you shove into the thing. Yeah, but it's still it's good, right? So, but yeah, no, it does have a screen. That the facing screen is not really quite the as good, I would say, as the screen that faces your eyes, which is fine for what it's worth, because that's all you really kind of need, you know. It's like, well, if I'm going to let some light come out, and it's like, all right, well then I'll, all right. So then it's constructively interfere, and then it makes this little weird kind of like holographic-ish, but you wouldn't know unless you like zoomed and enhanced. Like you got really close, and then you tilted it at the right angle. It's like, oh yeah, no, it's slightly off the surface there. Yeah, that's right there. Yeah, yeah. How'd you do that? There's a lot of bending of light using light, kind of stupid shit. Yeah. But it's like, no, that's a ridiculous viewing angle. You'd never see anyone's eyes there. So you that's stupid. You're just gonna see whatever. Go away. Go away. Yeah. So they're not quite the best, as like maybe like. But then I'm like, what is this? Like you think the clear substance known to man? What is this? That's that seems an unfair comparison. Just letting us, all of us that are listening to this, along with myself, of course, because I'm in the future. Anyways, moving on. All of you listening, just letting you know. So there's that. But it's like, and that's it basically. Like I kind of just started turning into like, what the fuck can I use this for? Like literally, what can I use it for? Yeah. And so I was like, oh, yeah, that's nice. Hmm. That's a lot of fucking time. How expensive were those glasses to make? They're not stupendously cheap, and round circles are nice this time of year, anyways. They're the best kind of glasses. Perfectly round circles. They're so easy and cheap, especially when the frame of flat fucking panels. The bendy nature. It's because it wants to be an airy quality, of course. That's kind of more of that closed in safety-ish kind of steampunky goggle look. Meanwhile, my ass that knows everything about what I'm doing, it's like, no, this is the cheapest fucking way to make this. This is just some and I can bend them, and then I just connect, and then and I'm done. And like, yeah, no, anything, well, or whatever, it's not gonna get through. That's good, right? You have like different viewing amounts for even welding. Like if you really want to weld, you can just use them straight as a welding, you know, uh, actual glass. Right, which is pretty phenomenal. But if you don't, then there's that. But it's like, yeah, no, they basically seal. There's slight bend and change and shift, right, kind of stuff for what that is, and so like they'll fit most of your faces, most, not all. You know, but there are different sizing options. So that one turns into small, and then medium, and large, and there's extra small, and then really extra small, and then there's oh my god, that's small, and then there's this one that says plank, which is basically like the smallest I could do. So there's that, and then there's this one that says it's sun, and it goes hyper giant, and then there's this one which is supermassive black hole, which is I'm just letting people know, really just a face mask at that point. It really is. It's like supermassive black hole over here. It's the face mask. It literally connects to what is effectively what looks like a helmet, space helmet for like a spacesuit, which is actually what I ended up turning that one into later on. But that's a whole other thing. So I'm gonna move on from that. It's like, oh yeah, no, it's totally able to be sealed. Yeah, it doesn't take that much to make. Yeah, it can see all the frequencies practically. It even bends radio waves. So like with enough bending, it captures it with the right, material to turn that into, uh, you know, like a sensor. especially if it's a part of your body, and so like movement and all whatever, right? And so you get like radio wave frequencies that you can literally choose to see. It's like these lenses, well, cool. It's like, yes, but you don't understand how cool. I can see everything that your fucking gut's doing in real time, and it just looks like natural light to me. So I know all the colors of the food, what your gastric is looking like. You have some plaques in those veins and arteries over there. Oh, look at that. You got a weird thing in your kidney, and that's a weird liver thing going on. What's that in your brain? It's whitening right there, and I see some weird EEGs and EC whatever fucking G, for your heart and your brain, whitening and blood flow to certain parts, and then electrical activity, change and all that with my glasses. So it says here that means you're likely like this right now. Your tonality, because the glasses, of course, can send pressure waves, right? But I'm hard of hearing. So like for me, it was like, oh right, yeah, no, that's perfect. These are great diaphragms. If you get them really thin like that, it's like these are really good diaphragms. I can make many different types of and it's like, behold, these attach to my eardrum. That's right, they attached to my eardrum. I'm not kidding. I'm not even slightly. They're so thin, and because I'm able to like make them work off of and so reactive off of my very just heat and bioenergy and all that shit, right? It's like, oh, I never need to charge them. And so I was like, well, if I get the right person to put these in there and I just shape it and then put these little, it's like it's lighter, it doesn't interfere with the eardrum, it still allows for air and all that to do its thing, right? And so it's like, I can hear like a normal person. All I have to do is have glasses on, which I already have glasses because I need them, right? Or any kind of sensor. You know what I mean? I'm not even kidding. Like it was effectively in a vacuum kind of like pressure, like a microphone, right? But it's like, right, I was able to effectively just put those around my ear anyways, or in and around, like, so it's like, oh, right. Well, that's a bunch of microphones. So it just sends it really quickly using light. Because light's faster and it's analog processing, and it can only really be these kinds of things, right? Then I'm able to do that. But it was like, right, if I want a higher frequency and I want to be able to hear that, I can turn it into a frequency I can actually hear, right? And then kind of same thing for infrasonics. So I ended up being able to see and hear way more than everyone else. Well, I could calculate with nothing, essentially, because I've got like a bunch of transistors that make no sense after a while. They're like, oh yeah, light is a transistor, and I can do that. I feel like electromagnetic field effect collapses, and and then I can do a lot of transisting. What can't I and with my programming that I have them? Yeah, no, I could easily. And then it turned into, well, my ears alone process a fuck ton of information incredibly fast, actually. Like way too fast. That kind of thing, right? Like, oh yeah, no, that's a supercomputer. Nice, neat. Yeah, I don't care. I have qubits. I have phononic resonant bullshitty qubit things that process and all that in my brain chips and whatnot that I've already put on my YouTube channel like several times and know how to program and all that. So it's like this isn't that hard. So then my glasses are just like extra icing on the cake, and then it turned into, yes, so I know all the things that you think I don't know at any given moment that I want to, and with my dimensional, uh, multi fucking layer hard drives and RAMs and so on for cache systems and all that, then it turned into, so these store all of the information that have ever been online and ever in any book and so on, and they can calculate ridiculous amounts of shit for like everything. And I'm like, computer scan my body. you know, put the glasses around and that's urine and smell sensor, which is another version of the same kind of thing with the glasses, the holes in them. So it's like as chemicals go through, like that's a different type of sensor. Anyways, I'm moving on. It's like, oh, so you seem to have these issues going on with you. It's like, yes, no, I know I need to drink water. You know what I mean? I get it. I know I need to. Fine, computer, I'll go drink the water. So you need to go drink the water, right? And then it's like same thing when it comes down to, oh yeah, no, it has an AI. It's a fucking totally god level, general intelligence, sentient, self-aware, you know, uh, all those things, human being, but really super hyper intelligent, like I am, kind of guy, and creative too, because I learned how to program that pretty easily. Turns out, right? And I was like, oh, and it really honestly uses almost nothing of my like computation ability. So I was like, oh, that's not that bad. And I have antennas and different frequencies I can put out. So I was like, satellites and any fucking Wi-Fi and solid data, and kind of want. I can be my own ISP almost. Well, I'm allowed to be, but move on. Because that was a whole other thing when it comes down to just like, well, I could just brute force everything and I don't have to care. Literally, after a while, I was like, no, I know where everything is. I can see where, that kind of thing. And like, whatever, So I'm gonna hear you over there, all the way around the world, because of chaos theory, mathematic bullshit with light and sound crap, and then I can just fucking look at you. So that one was fun. But it's like, well, so when are you gonna sell them? I'm not. There's no fucking person on this planet other than my ass who made this that will ever get these. Go fuck yourself. No. Everything about this tells me that's dangerous, and no. That sounds so dangerous. You guys are so dangerous. You could easily turn so many things into many dangerous things with this kind of thing. I was like, well, I could just. Whose bank account is that? And mine. What is that, encrypted? No, it's not. I can literally just look at the fucking cables and know everything that's going through them. And I'm not even kidding. Not just like ISP and like IP addresses, but what it's going towards, what it means, what it's asking for, and all the rest of it. And who's doing it, everything. So it's just like, yeah. Yeah, I don't know if I want to give people that. I don't know if I want to give a bunch of people that are like, QAnon and we will storm and destroy all the not Christians a chance and possibility. Even the Democrat, we will kill all the. And honestly, these things are bad. And but actually, that doesn't make any sense. That's not how that works. Like, there's just no, no, no. That's giving yourself special privilege. You damn bitch. They don't think it's a thing. I'm like, it's absolutely a thing. And you have like god level fucking shit like that. It's like, no, no. No, I'm not giving you this. Get out of here, you damn bitches. No, you can't even be trusted to have fucking scissors sometimes. Get out of here. Get you. Look at you. You cut your knife with another knife because you were like, can it sharpen it? And then that's after you like gave yourself several cuts on your own hand. That's disturbing. Come on. Can you please stop? Stop asking me to give you this. I'm not selling this. No. Get out of here. Meanwhile, behold, here's how to make it yourself if you so choose. If you're smart enough, if you're able to do it, and you know how to dope and all the rest of it, you too might be one of those individuals that can also have one of these things. Oh god. I'm still fucking very scared of that. I mean, it's really pretty fucking simple to make these things. If you know what you're doing and you look into it, it's like, shit. Okay. Oh god, yeah. Alrighty. Bye. Suck my chicken balls. Like and subscribe. Please share. Hit that notification. See ya.